acids. Okay, so preparation of carboxylic acid mein first we can prepare it from alcohols. So from primary alcohols, preparation of carboxylic acids from primary alcohols. You know, primary alcohol is like this: RCH2OH, means it is aliphatic, there are alkyl groups, and if it is aromatic, means benzyl alcohol and ethyl alcohol. Take them. So to convert primary alcohol into carboxylic acid, we can use acidified KMnO4 or potassium dichromate. Acidified KMnO4 or oxalic acid. Potassium dichromate. Okay, Ashish, thank you very much. So now, first of all, you know, these are oxidizing agents, acidified. You can write complete acidified. Okay, means KMnO4 with H2SO4 or K2Cr2O7 with H2SO4. So when they are oxidized, first they are converted into aldehyde. First of all, we get aldehyde. Okay, but if they are distilled at this point of time, then we can get aldehyde. Okay, but if it remains in the solution, it is further oxidized to carboxylic acid, because both acidified KMnO4 or acidified potassium dichromate, both are strong oxidizing agent, where it will not stop, reaction will not stop up to aldehyde stage. We get carboxylic acid. This is acetic acid and this one is benzoic acid. Right? Now, these aldehydes can be converted into carboxylic acid even by using, yes, tell me, is there any other reagent which can convert aldehydes directly into carboxylic acid without using these two? Yes, tell me any other reagent. We have discussed that one. Okay. I will try to fix it. Say, aldehyde, if we use Tollens reagent, what is, oh sir, good evening. What is Tollens reagent? What is Tollens reagent? Tell me. Tollens reagent क्या होता है? It is ammoniacal silver nitrate solution. Tollens reagent is ammoniacal silver nitrate solution that can also convert aldehyde into, you can write iron, carboxylate ion or acetic acid, 2 moles of this and 3 moles of OH negative. So we get, this is also called silver mirror test. You know that. 4NH3 and 2H2O. Right? So primary alcohols, to convert them into carboxylic acid, we use acidified potassium permanganate or acidified potassium dichromate. And to convert aldehydes into carboxylic acid, we can use these two, and even Tollens reagent can serve the purpose. Okay. Now tell me, can we prepare formic acid by using acidified KMnO4 or potassium dichromate? Can we prepare formic acid? Yes. See, if we prepare formic acid, we use CH3OH. On oxidation, we get formaldehyde. Further oxidation is converted into formic acid, but reaction will not stop here. Formic acid is further oxidized to give carbon dioxide and water. That's why we cannot prepare, we are not able to prepare formic acid by using these reagents. So our method cannot be used to prepare formic acid, right? Okay. At the same time, even benzaldehyde can be converted into acid. In, by using it in the presence of air. Voice अलग रख लिए. The presence of air. Voice अलग रख लिए. The presence of wait. Okay, wait. ओके, कंटिन्यू रखते हैं. थोड़ा बहुत मैं सुनता रहता हूँ ना. क्या क्या जुगाड़ करने पड़ते हैं. ओके, तो let's go to next page. Now this is from primary alcohols. Okay, Now we can prepare the same from secondary alcohols. Okay, but this time see, we first get ketone. Okay, this is isopropyl alcohol. After getting isopropyl alcohol, oxidizing it, so isopropyl alcohol is oxidized to acetone, right? Now to oxidize ketone, it is very difficult task. So we use concentrated nitric acid. What we use? Concentrated nitric acid. Now concentrated nitric acid can lead to the breaking of carbon-carbon bond. So we get carboxylic acid with less carbon atoms. So in primary alcohol, what we do? Primary alcohol first convert into aldehyde and aldehyde into carboxylic acid. Okay, with same number of carbons. Okay, here with secondary alcohol, first we get ketone with lesser number of carbons. Sorry, ketone with same number of carbons. Okay, and after getting ketone, it is further oxidized, and which leads to the breaking of carbon-carbon bond, and we get carboxylic acid, but with lesser number of carbon atoms. Okay, it's okay, Rishi. Then any doubt up to this? I think there is no doubt at all, but it's my duty to ask you. Yes, anybody? In case of primary alcohol, we use acidified KMnO4 or acidified potassium dichromate, and it leads to the formation of first aldehyde with the same number of carbons, carboxylic acid again with same number of carbon atom as that of alcohol. But in secondary alcohol, first we get ketone with same number of carbons, but carboxylic acid with lesser number of carbon atoms than that of the alcohol. Okay, done. So this is the second method. Now ketones, say ketones are oxidized with concentrated HNO3. Okay, but if we have unsymmetrical ketones, say there are symmetrical ketone, so first we get, say in this case we get methanoic acid. Methanoic acid gives carbon dioxide and water. What if we have an unsymmetrical ketone? Like this: CH3, CH2, C double bond O, CH2, CH2, CH3. Okay. So in this case, it is oxidized by using Popov's rule. Just tell me, what is Popov's rule? Yes, what is Popov's rule? Tell me. What is Popov's rule? No one? I think we have done it. Beta, Popov's rule. Popov's rule is, then oxidation of ketone takes place, then carbon-carbon bond breaks. See, there are two ways, from A side or B side. Tell me, which side is preferred side, A or B? Breaking takes place from A side or B side? Very good. That is called Popov's rule. That CO will go with that alkyl group which has lesser number of carbon atoms. Breaking takes place from that side where CO goes with lesser number of carbons. See, on left side there are 2 carbons, on the right side there are 3 carbons. So CO will go with 2 carbons. Okay. Beta J, B side is preferred. ए आशीष, पहले आपने ठीक लिखा था. Okay, CO will go with CH3. Okay, you have written that A. Breaking takes place from B. So we get CH3, CH2, COH, and again 3 carbons, means 2 moles of propanoic acid is formed. Moles of propanoic acid is formed. So for unsymmetrical ketones, their oxidation takes place as per Popov's rule. And what is the rule? That CO will go with alkyl group having lesser number of carbons, or we can say breaking of CO and carbon takes place from that side where number of carbon atoms are more. Break B hoga. Okay, great. So this is all about from secondary alcohol or ketones. So we have prepared carboxylic acid from primary alcohol, from aldehydes, from secondary alcohols, and from ketones. Now next is, let us prepare from alkyl cyanides, alkyl or aryl cyanides. So see, in alkyl cyanide, let us take alkyl cyanide or simplest aryl cyanide. Okay, so they are hydrolyzed. So when they are hydrolyzed, we get ethanoic acid phenyl cyanide, we get benzoic acid along with ammonia, right? Now, these alkyl and aryl cyanides can be prepared from alcohols that is used in conversions. Like if we have methanol. So methanol, from methanol we can get methyl cyanide, but methanol, methyl alcohol, first it is converted into methyl chloride or bromide, whatever you wish to, by SOCl2, or we can use PCl3, that you know all, PCl5. After getting this alcoholic KCl used, and we get methyl cyanide along with KCl. So that means methyl cyanide is converted into ethanoic acid, right? Acetic acid, but methyl cyanide can be prepared from methanol or methyl chloride. Okay, so convert alcohol into carboxylic acid with one more carbon. Say in alcohol there is one carbon, in alkyl chloride there is again one carbon, but in carboxylic acid there are two carbons. So if we have to we wish to increase one carbon in the chain, we use KCN. Okay, ascending of series means. Same, to get phenyl cyanide, we can prepare it from aniline. Aniline, to convert into cyanide, NH2 to cyanide, first NH2 should be converted into diazonium salt. Aniline into diazonium salt. To convert into diazonium salt, okay, Harshil, good evening. NaNO2 HCl at 273 to 278 Kelvin, and then CuCN and KCl. So we get C6Cn. Okay, so phenyl cyanide can be converted into benzoic acid easily by hydrolysis, right? So this is from alkyl or aryl cyanides. So let us convert ethanol to propanoic acid. Let us take this case. Ethanol to propanoic acid. So just think, in ethanol there are two carbons, in propanoic acid there are three carbons. So obviously KCN should be involved. So to involve KCN, we need halide. That means that is the way to think about conversions. Ethanol. So ethanol first converted into ethyl chloride, right? By using PCl3. So if we use PCl3, POCl3 is removed. Now ethyl chloride treating with alcoholic KCN. How do we know that KCN should be used? Because there is ascending of series. Carbon atoms are increased by 1. If carbon atom is increased by 1, so we should use KCN. Done? So now on hydrolysis, hydrolysis, we get propanoic acid. So ethyl alcohol to ethyl chloride, ethyl chloride alcohol to ethyl chloride to ethyl cyanide, and ethyl cyanide to propanoic acid. That's it. Any doubt? Now, next is, okay, no doubt, that's it. From, or simply you can write by alkaline hydrolysis of 1,1,1 trichloro trichloroalkane. Any 1,1,1 means 3 chlorine should be on the same carbon. Such is any alkane having 3 carbons is halide, trihalide, where all the 3 carbons are on the 3 chlorines are on the same carbon. R C 3 carbons on 3 halogens, sorry, on the carbon means it is at the end terminal. So use sodium hydroxide. So sodium hydroxide, when it is treated, X are replaced by OH, NaX, three NaOH are added and 3 NaX are removed. And you know, when 2 or more than 2 OH are on the same carbon, then what would happen? Water is removed. So we get carboxylic acid. See, it is like this. H plus and OH negative. So C double bond O and OH is formed. Means carboxylic acid we will get. For example, if we have CH3, CH2, chlorine, 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 treated with sodium hydroxide. So we get CH3, CH2, OH, OH, OH. Right? After getting this, now 3 OH are on the same carbon. So obviously unstable stage. So water is removed and we get CH3, CH2, COH. So we get propanoic acid. Done. So this is by alkaline hydrolysis of 1,1,1 trichloroalkanes. Next one. By the hydrolysis of esters. Now, hydrolysis of esters. So you know, ester are R, C double bond O, O dash. So ester are hydrolyzed in alkaline or acidic medium. Acid like HCl or H2SO4, mineral acids, or base like sodium hydroxide, potassium hydroxide, then in both cases we will get from your carboxylic acid along with alcohol. But as soon as they are formed, they should be removed from the mixture, because if alcohol remains in the mixture, reaction can be reversed. Right? So as soon as acid is formed, alcohol should be removed. Otherwise, reaction becomes reversible. Like let us take an example: CH3, CH2, C double bond O, O, CH2, CH3. It's ethyl propanoate. It is named as ethyl propanoate. The part attached to O is called alkyl and other part is OH. So ethyl propanoate, when it is hydrolyzed, acidic or basic medium, then tell me what are the products formed. It is your turn now. What are the products formed? Fast. What are the products formed? Okay, great. First we get CH3, CH2, CH3, CH2, C double bond O, along with OH, CH2, CH3. That means propanoic acid and ethanol. Propanoic acid and ethanol. Right? Done. Very good, Ashish. What about others? बाकी क्या कर रहे हैं? हाँ, CH. Okay, it's okay, it's okay. Now tell me if we have yes, what are the products found? Now, fast. यार सिंपल सा केस है. It is actually C double bond O. And CH3OH, because it can be written as C double bond O, O, CH3. Very good, Ashish. C6H5 COH and CH3OH. Rest are sleeping. They are in sleeping mode. Now next is very good, Basant. Good. By alkaline hydrolysis of compounds containing active methylene group, or we can say active methylene compounds, right? By alkaline hydrolysis of active methylene compounds. Now, active methylene compound means when carbon is attached to electron withdrawing group. Carbon is attached to active methylene groups. Now tell me, what are the products formed in these cases? These are the two cases. Okay, Harshil, you are in listening mode. Now tell me, what is the product formed by alkaline hydrolysis? Sorry. Alkaline hydrolysis of ester. Or you say again, these are two esters. So ester hydrolysis takes place when it is hydrolyzed gem dicarboxylic acid. Gem dicarboxylic acids are formed. And keep in mind, when two COH are on the same carbon, decarboxylation takes place easily on heating. Decarboxylation takes place easily on heating. So when we heat it, that is, we get acetic acid. Carbon dioxide again removed. So we get CH3, CH, CH3, COH. So 1, 2, 3. 2 methyl propanoic acid. 2 methyl propanoic acid, or we can say alpha methyl propionic acid, right? We can write it as alpha methyl propionic acid, means common name. Okay, so active methylene compounds means if carbon is attached to two electron withdrawing groups. When carbon is attached to two electron withdrawing groups, that is called active methylene compound. Right? Next one, by the carbonation of Grignard reagent. See, if we have a Grignard reagent and we would like to increase one carbon to form carboxylic acid. So what we do? We use carbon dioxide. Okay, we have carbon dioxide. It's carbon dioxide. Treat it with RMGX, Grignard reagent, and Grignard reagent is always used in dry ether. So R is negative, MgX positive. So CO, it is like this. Pi electron transfer towards oxygen. Oxygen gets negative charge, carbon gets positive charge. So R is attached to carbon. And O negative and MgX plus, which on hydrolysis gives carboxylic acid along with MgXOH. Okay, let's, we have simply methyl magnesium bromide or phenyl magnesium bromide. Tell me the final product. In dry ether, tell me the final products in both the cases. In first case, what will we get? Very simple. And in second case, what we will get? Yes. Yes. From the product. First we get addition compound, and then on subsequent hydrolysis we get carboxylic acid. So very good, Ashish. Again same CH3, C double bond O, O negative, MgBr positive bond. Good, Saad, very good. Harshil, propanoic acid. Propanoic, Harshil? How is it possible? Only one carbon atom is increased. So it is methyl, so that becomes benzoic acid. Okay. Very good. So good, Harshil. So we get acetic acid along with MgBrOH, C5, COH along with MgBrOH. बाय नहीं, अभी करना है बेटा हमें, अभी तो बाकी है. Now next is by the oxidation of अल्काइल बेंजीन। ठीक है, अब अल्काइल बेंजीन में यू नो simplest is methyl benzene, that is toluene, or ethyl benzene, isopropyl benzene, ठीक है, और टर्शियरी बेंजीन। अब देखो मिथाइल बेंजीन, इथाइल बेंजीन, आइसोप्रोपाइल बेंजीन, आइसोप्रोपाइल को क्या बोलते हैं, क्यूमीन, है ना। तो इन सब की अगर ऑक्सीडेशन करें इन एसिडिफाइड KMnO4 या एल्कलाइन KMnO4, चलो सब में सेम यूज कर रहे हैं, KMnO4 and KOH, ठीक है। तो फर्स्ट ऑफ ऑल in all the cases we get potassium benzoate irrespective of the number of carbons in the alkyl chain. We get potassium benzoate along with carbon dioxide and water. Hydrogens are converted, extra hydrogens are converted into water and extra carbons are converted into carbon dioxide, ठीक है। अब इसकी कंडीशन क्या है, दैट कार्बन जो है देखो कि जो बेंजाइलिक कार्बन है दैट शुड हैव at least one hydrogen. See, in this case, benzylic carbon attached to ring, directly attached to ring, that is called benzylic carbon. If benzylic has no hydrogen, no reaction takes place. Oxidation does not take place. समझ गए? That is the main thing about it. On acidification, we get benzoic acid. Cl is removed. That's it. ठीक है, तो बेटा अल्काइल एक क्लियर हो गया पॉइंट। अल्काइल बेंजीन, इन अल्काइल बेंजीन benzylic carbon should have at least one hydrogen, then only it is oxidized, and except benzylic carbon all other carbons, carbon bond break and they are removed from the main product and converted into carbon dioxide and water. Say in tertiary butyl benzene, this is tertiary butyl benzene. In tertiary butyl benzene, there is no hydrogen on the benzylic carbon, or we can say there is no benzylic hydrogen. That's why it is not oxidized. And if even there is chain of many carbons, even then on hydrolysis we get potassium benzoate along with carbon dioxide and water. How many carbon dioxide and water are formed? Depending upon number of carbons and hydrogens. Okay, done. Understood about alkyl benzene, oxidation of alkyl benzenes? Next, from methyl ketones. Methyl ketones, you know, CH2, CH2, C double bond O, CH3. This is methyl ketone. Only it is applicable to methyl ketones only. Methyl ketones, when treated with sodium hydroxide and halogen, take it iodine. Iodoform reaction, or simply it is haloform reaction. Okay, so in this case, methyl is converted into iodoform. PPT, and along with sodium salt, sodium iodide and water. Okay, it is test for methyl ketones as well. Okay, we have done it in ketones. So 4 NaOH and 3 I2. Okay, so from methyl ketones, when the methyl group attached is converted into iodoform, or any, if it is X NaX2, then haloform along with sodium salt of carboxylic acid and sodium halide and H2O. Okay, what happened? NaOH is treated with iodine to give NaOI, NaIO3 and H2O. Now you're teaching very level, sir. I couldn't understand. ठीक है, तो ये हो गया from methyl ketones by using haloform reaction. Now next is from alkene, Koch reaction. So Koch reaction में क्या होता है? Let us take alkene, carbon and steam. Carbon monoxide and steam is passed through it in acidic medium. So we get CH3, CH2, COH. Yes. CH3, CH2, COOH. Propanoic acid. Means one carbon atom is increased. Okay, thank you, yaar. Mera Vasant, thank you. Sangeeta Kumar, thank you very much. See, CH3, CH double bond CH2 plus CO in steam, medium acidic. Just tell me now where COH is attached, at CH or COH? Okay, Vasant, you are Tamilian? COH is attached at CH or CH2? Okay, very good, Ashish. Okay, Vasant, good. So it is like this: CH3, CH, CH3, COH, or we can write it as C, CH, CH3, COH. That is 1, 2, 3. 2-methyl propanoic acid. Very good, very good. Bismya Kumar Naik. Good. So this is called Koch reaction. This mineral acid is either H2SO4 or phosphoric acid under pressure, because you know steam and carbon monoxide is passed through alkene under pressure, propene or ethene. So ethene is converted into propanoic acid because it is symmetrical, but in this case when it is unsymmetrical alkane, COH is attached to CH site. Done? Okay, so this is called Koch reaction. Now next one, by the action of nitrous acid, nitrous acid or acidamide. You know, acidamide is CH3 COH. CH3CO and H2 when treated with nitrous acid. You know, nitrous acid is prepared in situ by using NO and HCl to give HNO2 and NaCl. So how it behave? See, we have CH3CO and H2 HONO. Okay, so we can write like this: CH means to remind CH3COH along with N2 and H2. So we get acetic acid from amide by using nitrous acid. Done. If it is aryl 11, same type of reaction takes place. Okay, so ये हो गया. Now by passing carbon monoxide through heated or on heated sodium alkoxide, by the action of, or we can say by passing carbon monoxide on it, we have sodium alkoxide, this carbon monoxide is passed under pressure heating under pressure. So CO is inserted into it. We get sodium alkoxide, which on acidification we get carboxylic acid. For example, if we have CONA or C6H5ONA, on treating with carbon monoxide, on heating and under pressure, same conditions. So we get CH3CONA, C6H5COONA, which on acidification we get acetic acid and a benzoic acid. Sodium chloride is removed. So that's all about the preparation of carboxylic acids. Any doubt up to this?